So we're live again. Hi, hello, and welcome everyone. Microbehunter here. Welcome to another Saturday Microscopy live stream. Yeah, today I'm going to show you some Paramecia in an electric field. I actually did manage to get that done. I'm going to show you how I'm doing that, and I'm also going to show you some almost 23-year-old microscopy videos. One of my first microscopy videos that I ever made, and yeah, we're going to have a look at those as well. I see that a lot of people already started posting, and yes, sound seems to be good. Somebody's already telling me, and that's great, because with the new microphone here, maybe their sound might not be quite fine. The first couple of minutes, I'm going to simply say hi to everyone around the world, because it takes a couple of minutes for people to join into the live stream. So this is the time that I usually use to read through the first couple of comments where people actually send greetings from all around the world. Okay, greetings from Vienna, okay, from Vietnam, and also from Germany. It's very nice. I traveled to a fishing village on an island where there was a lot of shells, algae, and seaweed. Okay, and I completely forgot to bring a sample. Okay, hello from England. Sound is good. Greetings to Oliver, to me. Video too is great. Okay, good evening from the UK. Sound is good. Utah, United States. Okay, so yes, here we are again, and I think we're ready to go as more and more people started to join in. What I'm going to do today is the following. I'm going to show you this little slide that I've made. Well, actually, you know what? I'm going to start from last week, because last week I showed you this little slide that I got. It's called the Micro Life slide. If you've been here last week, then you already know how it works. You're able to put in a sample in here, and then you are able to observe the water life as it travels across here. And this is like a micro aquarium, and according to the instructions, you are able to store samples, some samples for several months. Okay, so yeah, I've not tried this yet, of course, but what I realized here is I realized, well, actually this would be an interesting device as well to observe how Paramecia, these are single-celled microbes, microorganisms, how they react in an electric field. And as a matter of fact, I'm going to show this to you. It actually did work today in the morning. However, I will not be using this here because it's not quite practical, but rather I made myself another slide here, and I'm going to show you how I made it. And I'm going to simply explain this to you, okay? So maybe I'm going to go a little bit closer. So what you can see over here is this is just a regular microscope slide. And here this is a copper wire going around it, and I glued it on the slide. I glued it using super glue and baking powder. I'm going to show you how this works. The baking powder method with super glue is really a miracle combination. And what I'm going to do then is I'm going to put the Paramecia, the water sample with the microbes on here. Cover glass, of course, goes on top. And then I'm going to connect it to a DC power source, the other side, yeah, plus minus. And because I extra bought a power source simply for this experiment. And then we're going to see how the Paramecia react. I will give it away. They will move towards the negative pole. This is the cathode. The negative pole is this is where they're going to move towards, and you're able to see that, right? And then if you change the polarity, then they're going to change direction and going again to the negative pole. Yeah. So this is a really an interesting, fun thing. Of course, this effect has already been known for a long time, and if you are also a subscriber, excuse me, to the channel Journey to the Microcosmos, it's another beautiful microscopy channel. They've actually some time ago even talked about this very topic. Okay, so this is quite an interesting thing here. That is one thing that I'm going to show you. I'm going to show you first how I made this, how I glued it, because gluing something like this might not be so easy, but it was actually quite easy to do in this case because of the way that I glued it. And then I'm going to also show you later on some old videos that I made 23 years ago. And then of course Q&A, question and answer session, as always. Okay, so Yeah, so basically this is how it looks like, and I'm going to show you on a demonstration, a very quick demonstration, how I've actually glued it. So I'm going to move a sheet of paper here so that I do not damage the surface here. And what I used here is I used a little wire. It's actually not a cable. You probably know those, right? This is actually to tie together some cables. Yeah, I'm going to just use this as a demonstration. When you kind of remove the insulation material, you're going to see that there's only one wire. Okay, and what you do is the following: is you need some super glue. Okay, this is just cyanoacrylate super glue and baking powder. It's just regular baking powder, right? And this is a well-known combination because this is a miracle. Honestly, this is a real miracle. Glue. What you do is you take the liquid. It's a very thin and very liquid super glue, and you simply put a few drops on here, and yeah. It might glue more or less well, okay? Of course, you do not want to put any glue here at the actual electrode. And then, yeah, all you do is you dump some baking powder over it, okay? And what's gonna happen, and you spread it around, and it's immediately going to react with the super glue. You knock off the excess baking powder, and this almost now becomes hard as rock, okay? It's very, very strong, okay? So the super glue and the baking powder, they react, and yeah, if you get something on your fingers, and sooner or later you will get some of the super glue on your fingers, don't panic, because the fat of your skin is going to cause the glue and the baking powder to peel off, right? Yeah, and if you want to make it even stronger, you can add another layer of super glue and add some more baking powder, and this is how you can actually pile it up, and yeah. So it's a very fast and very reliable and strong method to glue together, yeah, smooth surfaces as well. And let's see, I don't know, I can try to remove it. I'm gonna try to rip it off. Yeah, it does go off, but you do have to apply a little bit of force. It's strong enough. It's not even completely dry yet, that's why it went off, okay? So I just wanted to show you how you can actually make this yourself. What else can you try to do is you can try to use kitchen aluminum foil maybe. That would be a possibility. You could try to use a tin can. Okay, you would simply cut apart a tin can, which is also aluminum, and try it like that. You can try many ways, right? What I have done here is I simply glued some wires here, and we're going to go back with that. Okay, so what I'm going to do now is what I'm going to do now is I'm going to simply remove this again because we don't need this, okay, anymore. And we're going to now start with the microscopy. And if you joined in or if you've seen this live stream a couple of weeks ago, you might remember that I was not so lucky with the Paramecia because the Paramecia density was not quite as high as I hoped it to be. Let me quickly put this away, the baking powder. Okay, but today in the morning I was a little bit more lucky, and so hopefully we're able to see a little bit more today. Okay, so I've got here a sample with Paramecia. Okay, so it's a water sample. You can see there's some algae in here. I found out that Paramecia really like to be around algae, I suppose, because there's lots of oxygen there as well. And I need some tweezers. Okay, and I'm going to simply apply now some of the sample on here. Okay, I'm going to, in the meantime, also before I do that, quickly go through the comments again so that I do not miss any. Still, hello from California. Okay, from the US, from the West Coast. Yeah, dancing microbes for this. I don't know if they're dancing, but the microbes are going back and forth. Excited about that. Does anyone have tips on how to photograph good images of amber with insect inclusions on a stereo microscope without zoom? Oh, that's a long topic. Okay, it's also a good idea to first place the baking powder and then add the super glue. That's oftentimes more precise and cleaner and it dries quicker. That's also a possibility. You basically put the baking powder first and then you take some very thin super glue. Okay. Without zoom, well, I guess it will help if the insect slide is made from U-Pearl. Okay, so let's start doing this here. So what I usually do is the following, and there will be a lot of algae here as well, okay? But the Paramecia should not be a problem. And what I've done today in the morning, I've taken out those algae, I dipped it here. And you're going to probably, you won't be able to see this. It's a little bit green because there are lots of diatoms as well. Okay, I have to be careful that I do not move out of the out of the picture here. Okay, and because the wire itself is fairly thick, Okay, it maybe is a good idea also to add a little bit of liquid directly, but I won't do that just yet. Because I will first add a cover glass. Now I've got those pretty large cover glasses as well. Okay, they have advantages and disadvantages. Okay, because they go all the way to the edge of the microscope slide, there is a little bit the danger of it spilling. Okay, and as always, yeah. I have to remove some of the dirt because even when they're fresh out of the box, they're not entirely clean. Okay, and usually you place it on here. And what is really important is that there is a good contact of the liquid with both wires, and this is not the case. Okay, and for this reason, I'm going to add a little bit more liquid here. Okay, you may be able to, yeah, you're able to see how this fills up, right? And I think this should be enough. Okay, I don't know if you're able to see this, but yeah, there is now liquid, hopefully with plenty of paramecia, from electrode to electrode. Okay, and yeah, we're going to have a look at it first, and then I'm going to show you the power supply that I have, and we're going to connect it, and then yeah, we're going to play around a little bit. Okay, so scene microscope, so I have to use the microscope view now. And we just simply carefully put it in here. Okay, and let's see if this kind of works, and let's hope for the best. Are we able to see paramecia here? Yeah, sure we are. Okay, here we go. A little bit more light, maybe a little bit down with the... Okay, here we go. It's not quite in focus, that's okay. Here we go. Because of the wire, because the wire is fairly thick, for this reason, of course, the paramecia will move in and out of focus a little bit. Okay, so let's move it further in here, and let's see if we're able to see. Yeah, see here. This is basically yeah, that's one wire. Okay, I think that's one wire. Yeah. And on the other side here, this is where we have the other wire. And what we're going to see is when I connect the power supply, we're going to see that the wires also will start to form bubbles. Because on the negative electrode, on the negative wire, this is where hydrogen gas will form, and on the positive one, oxygen gas will form. And we're going to see that the paramecia should actually start to move towards the negative pole. Okay, so yeah, you know what, let's go up, so this is the 40 times, let's go up a little bit with, maybe this is not the, yeah, let's go up with the intensity a little bit here, okay, and you see the, let's have a look here, you see, of course, there are the slightly larger cells, well, there are lots of, not only paramecia, but there are also rotifers moving around, and those smaller ones, these are not paramecia, these are the ciliates, okay, but what we're going to see is that not all of those respond in the same way, and that we have to actually look specifically for the paramecia, because they should start to move. Okay, and the string-like structures that you see, these are some algae. Okay. Okay, let's see if we're able to. Let's see if we're lucky here. So I'm now. Yeah, here are plenty of paramecia. I'm going to now show you on the side a little bit the power supply. What I have to change now the camera a little bit. I'm going to turn it over. Okay, so what I have here is a power supply, and when you there are two cables connected here, and this is the main switch. Okay, and I can adjust the voltage here. So what I'm able to do right now, I've got 0 volts, and when I turn it up, and I can go all the way up. It's not connected yet. Okay, so all the way up to around 30 volts, right? 29.87, and there is a fine adjustment knob as well, so I can go over 30 volts. Yeah, it's gonna kill the cells at this voltage. Today in the morning I accidentally killed all of them. Yeah, we can still try this out if you want to. But at around 10 volts, that should be the voltage which should all work fine. Okay, so that's kind of the thing. Okay, and let's put it back again here, so that you're able to see again a little bit. Yeah, and what I'm going to do now is I'm going to where is the cable? Okay, here am I able to see this? No, you're not. It's too short. So I've got here the cables. Okay, you just in the corner you're able to see it. Ah, here, down here. Why not use this here? Okay, here. Okay, and I'm going to connect one of them now to the negative pole. Okay, and watch what happens. Hopefully, I've got now 9.99 volts. Okay, and the other one I'm now going to connect to the other one. Okay, and as soon as I do that, let's hope that the Paramecia will start to respond. Do they respond? No. I'm going to go up with the voltage again a little bit. They don't respond. I don't know why. What I'm going to do now is, this is kind of funny. Go, somebody says, and they don't. That's a demonstration effect. Isn't this beautiful? Okay, you know what I'm going to do? Maybe it doesn't make. I think it doesn't make proper contact. I think there's an air bubble there. You know what I'm going to do? I'm going to add a little bit more liquid. Carefully there. A little bit more liquid. I hope I'm not going to miss this. So, it works. I think there was an air bubble. Okay, and where is the negative pole here? The negative pole is over there. And if we're lucky, we should be able to see that after a couple of minutes they start to accumulate there. Where is the wire? Okay, I don't see anything yet. There should be bubbles. Yes, there are bubbles forming on the wire. Okay, good. Bubbles forming on the wire actually means that there is now a response. Go a little bit down. I don't want to go too much with the voltage. Okay, so we've got electrolysis happening here. Okay, and there are now more here, and on the other side there should be less, and there are less. So what you see here they're less, and on over there should be now more. As to move over. And as a matter of fact, what I've seen today is that in the morning it actually all lined up very nicely, close to the voltage, close to the wire, I mean. And I'm going to wait a little bit longer, and let me see if this actually makes good contact. Because what I would like to do is I'm going to then later, of course, going to reverse everything. Let me add a little bit more water. Maybe there is indeed a little bit too little. I'll move out of the way here. Let me add a little bit more here. Okay. The bubbles forming are always a good indicator that, and over here and are less. But what I'm going to do now, maybe we're able to see this better. In the morning, again, this was really, really strong, the effect. But what I'm going to do now is I'm going to simply do the following. I'm going to move here, and I'm going to reverse the polarity. So maybe we're able to see this then as well. So very quickly, let's reverse the polarity, and let's see if they're moving into the opposite direction. So I reversed it now. Yep, and look. They are now moving here to the right. Let's check here. There should be less here again, where there were more. And now they're all moving to the right. Yep, the migration has started. Let's follow them here. Yep. And they did not want to touch the wire. Most of them did not want to. They kind of held short of the wire. Let me refocus a little bit. Yep, there are more coming. And I don't know, maybe I'm going to around 10 to 12 volts was the thing that worked quite well in the morning. If I go up too high, it's also not good. Let's see if I go up a little bit more. Say 13 volts. Not too high because I don't want to kill them, because actually this is what I did. I turned it up too high. And maybe some of them are actually already dying there. Maybe not, let's not go too high. And I'm going to reverse it again. You should move to the left. Yep, and they're starting to move to the left now, again. I've seen that rotifers usually don't respond, yeah, but Paramecia do this quite well. It was actually, you know what I'm going to do? I'm just going to leave it now a little bit because maybe they do accumulate after some time, because they actually lined up, yeah. They didn't want to go closer. But one of the things where I find some application for this is this could be maybe a way to concentrate the Paramecia, because you can selectively concentrate them. But occasionally, what I've seen is occasionally some of them do move into the opposite direction as well. You know what? Why not just go a little bit up with the magnification here, and maybe that's a little bit better to see. Yeah. So wiggling around, and here these are the bubbles already from the electrode. And on the other side, look at this. The smaller ciliates also seem to be moving. Look at the smaller ones. They're also statistically moving towards the left. Not only the Paramecia, but also the smaller ones. That is interesting. So you know what? I'm going to wait a little bit now. Maybe they do accumulate. Let's go down a little bit with the voltage, so not to 10 volts now. Yep, there is a migration now also of the others. Okay. Yeah, this is, now using the 10 times magnifying objective. More. Let's check the other side. Yeah, there's still a few of them here. Some rotifers and some cells, but on the other side here, we refocus at the negative pole. There is more going on. Yeah, so this is, I'm just going to be a little bit now more patient. We're just going to wait a little bit, and maybe at a lower magnification we're able to see maybe hopefully better. That's too bright. Maybe at a lower magnification we're able to see this better, where they accumulate. And I'm going to move this away. So this is now pure bright field, simple bright field. Do you know what I think? I think I might have, many of them don't look quite alive anymore. Maybe I was a little bit too high with the electricity. Here, look, here they start to build up. And somehow they do not want to go closer to the electrode for whatever reason. But let's wait a little bit here. Here's a nice line. Here we go. And here is again the electrode. And on the other side, here are also a few, but they're less. Yeah. Would be really interesting to do a little study on. Would be interesting to do a little study on the optimum voltage. But these are not Paramecia. These are some other microbes. Yeah. So let's have a let's wait a little bit here. A couple of comments again. Where is my mouse pointer? My mouse pointer is here. Yeah, depends on. Okay, I'm just going to skip over the comments that are not directly for me, because some people in the chat are communicating also with each other directly. Okay. Okay, I'm just going to read through. They talk about the microscope. Do you see any current flow on your DC supply? That's that's an interesting one. There is the current is very low. The current says 0.000. I also actually measured this out because I couldn't believe this, that there is no current. I measured it out with a voltmeter and the battery even, and connected several, and even there the current was 0. So it would be kind of interesting to also check if the small current that is flowing actually has this impact, or whether it's just the electrical field. I don't know. Okay, so this is something that would be the next thing for me to try out, to completely insulate the wires and have no current, definitely no current flowing, and then to see how if this has an effect. Okay. Yes, I'm gonna skip over. It depends on the magnification. Okay, do you say any current flow? Okay. Add 1 grain of table salt to increase or fasten the effect. It would be interesting. I don't have any table salt with me. Maybe I'm going to quickly jump up and get a little bit. Okay. Maybe a funny question, but why do the Paramecia go to the negative side? It's known as Galvanotaxis. I don't know if why this is the case. Look, wow. I mean, it is normal for, or not unusual for microorganisms. I mean, there are known microorganisms that are able to respond to magnetic field, for example, magnetic fields. So I do not know. I wouldn't know what the advantage is because where in nature do you actually see electrical fields? But I think this has to do something with, I read somewhere, with the beating of the cilia, because there is a membrane potential somehow, and somehow the polarity and the electric field changes the membrane potential, which influences the way that they move, because it influences the beating of the cilia. So maybe there is not even an advantage, or an evolutionary advantage, or a biological significance to this, because we might not have these electric fields in nature, but maybe it's simply a response in that due to the biochemistry or electrochemistry of the cells. Yeah? So it's a hypothesis that I have. Yeah. So some kind of them seem dead. Is the right of the threshold of what? Yeah, some of them do seem to. You know what I'm gonna do is I'm going to simply try it again. Okay, because while it did work, the effect that I had today in the morning was actually much stronger and nicer. And you see that over here, these are all rotifers, and they don't seem to care so much, I think. Yeah, and it could also be that over time, maybe as the hydrogen gas and oxygen gas build up, that this might also have an influence. Yeah. So I'm just going to disconnect it, and I'm going to try it again. Okay, why not? That's always one of the things that you do in the sciences. You simply keep on trying until you optimize it. So I need some tissue paper. Here it is. Here we go. So I'm going to remove all of those. You want to see what I'm doing, of course, so I have to change the view. So I'm just going to, lots of bubbles here because of the hydrogen gas, and if you put a little fire here, it's going to go like poof, and it's going to explode because of the hydrogen gas. It's not a lot really, but yeah, it does actually work. So let's quickly clean it off. Okay, and let's give it another try here. Okay, so it could be maybe that the wires also start to oxidize a little bit, so one has to be also aware of that. And let's give it another try. I know that there are lots of Paramecia here in the algae. So let's get some out here. I'm going to add now a little bit more of the water. It could be that I've now flushed them, so let's mix it a little bit. And let's add a little more of this here. And hoping that this is now also going to work. So now again have made reasonably good contact. Maybe a little bit more here on the side. I need a little bit more. There are some air bubbles here. So I'm going to add a little more. A little more. So, okay, let's give it a try now. Let's give it another try. We carefully put it back here again. Okay, in here. Okay, I have to switch over to the microscope view again. And let's find some. Yeah, here are again a few of them. So, and I'm going to connect them again, and let's see. This has an impact. So I'm not going to go too high now. I'm going to go, let's say, about 8 volts, because maybe too high of a voltage does kill them. So, and now it's connected. Let's see if there is a response. Okay, so that's around 8 volts, and they're moving. Which direction are they moving? Not into any direction. So maybe 8.3 volts is not quite high enough. Let's go up a little bit more. So I'm now at around 10 volts. They should be moving in my case, the negative pole is on the right side, so they should be moving towards the left. That is basically the place where there should be fewer, and we do not see a lot of bubbles forming. So this basically means it's only one bubble. So this means that electrolysis is not really happening very much. But okay, over here there are bubbles forming, so that is the negative pole. And I'm going to now leave it at around 10.5 volts. And I'm just going to check if they start to accumulate here. Over time. Sometimes it's a little bit difficult to distinguish the Paramecia from the rotifers. So maybe go up a little bit with the magnification here. And brightness. Yeah, there are lots of rotifers. Yeah, but you can see again that many of the small cells are moving here towards the left. It's the way it's supposed to be. And on the other side, there are now much fewer. I can imagine that maybe also the all of the algae that you see here, possibly diatoms and so on, that they might inhibit also the movement a little bit. Yeah, here. Now there are quite a few here. Let's go down with the magnification again. And let's wait. so let's have a look here. Would a battery also work like a 9-volt block battery? I tried it and it didn't work. Or maybe I didn't try it long enough. So what I would probably do is I would probably connect several 9-volt batteries in parallel. So maybe also some of them in series to increase the voltage to 18 volts maybe. But I would also try maybe first 3 or 4 of them in parallel. Yeah, and maybe this also works. I have a question. I was walking into my studying room and I saw a bottle of water, but there was no water in the bottle. When I looked closely, there were small green dots. I wonder if they are algae, if they're small green dots. Most likely they're algae, because it could be also the humidity in the bottle, maybe also the humidity of water that condensed, maybe also allowed them to grow. Okay. Yes, concentrate them, and perhaps for other critters as well. Brine shrimp, cyclops, ostracods, and other crustaceans. Interesting experiment. I do have, if you were a couple of months ago, I did some, I was growing some some little tiny sea monkeys, as they're called. So that would also be interesting to observe them. And I've also tried the following some time ago. I found a little flatworm, and I did connect a 9-volt battery, and every time when I connected it, the flatworm started to twitch a little bit. And it doesn't surprise me, because they have a nervous system, and if you now pass electricity through the water, then of course this stimulates the nervous system, and the flatworm was twitching a little bit because the muscles were contracting. So maybe the electricity either stimulated the nervous system and or maybe the muscles to contract. So that's something that can be observed as well. Okay. This is the first time I didn't miss your live stream. Okay, hello from the Netherlands. Okay, I'm definitely trying this at home. Thanks. I wonder if nematodes would react. Yeah, I would say it wouldn't surprise me, because nematodes also have a nervous system, right? And they have muscles, and muscles can be stimulated by electricity. So I would not be surprised. Ooh, talking about nematodes, I have a bottle of nematodes there. I never tried this. The vinegar eels. Honestly, you know what? I'm gonna try it, but no guarantee that it works. Okay, but let's wait a little bit longer. So okay, I don't see any. Where are they right now? That's interesting. First they gathered there, and then I don't know. It looks like almost like they're dying or something. No, they're too small to see here. Okay, now I go up with the magnification. Here we go. Okay. That's now at the negative pole. Again, these are not Paramecia, right? But other ciliates. But on the other side, they're much fewer. You know what I'm gonna do now? Now that there's so many of them here, I'm gonna try the nematodes as well. Okay. I'm going to now do the following. Let's switch on DIC simply for better contrast and color. And let's see what happens when I first disconnect, and then I'm going to switch the polarity. So it's disconnected now. Polarity is now switched. Into which direction do they move? Where are they now? They should go into the other direction. They should be moving over. Let me go lower magnification again. This here, and maybe they're going to collect on the other side now. I lost them. They're already gone, I think. This was fast. That's some of the Paramecia now starting to move to the right side here as well. I'm going to go up a little bit with the voltage just simply to check. Yep, and some of the cells are now moving again. So I'm now at around 12 volts. So let's focus again. I'm quickly going to go up all the way, 15, 16 volts. This makes a difference. But again, some of them start to move now. But so interesting. Again, the rotifers, they don't seem to respond. Even though actually the rotifers, actually, because they're micro animals, they should also have a nervous system. So it's quite interesting. Yeah. Maybe the chemical composition of the water directly next to the electrode is not optimal and oversaturated with oxygen, hydrogen. Not only that, but also the pH changes. So that is actually could be a problem. If there's hydrogen generated, then the pH drops, so it's very acidic. And I can imagine that this is maybe the thing that actually also kills them. From your experiment, would their population between north and south poles be a good indicator to verify the polarity of the magnetic field? Let's put it this way. Let me answer this. There's the question from your experiment, would their population between north and south poles be an indicator to verify the polarity of magnetic fields? I know that there are microorganisms and bacteria that are magnetotactic. This basically means they are able to follow magnetism, but if you want to observe that, well, you really need strong magnets. The magnet strength is much more than the actual magnetic field of the Earth. I don't know if this would be a good way to actually verify the polarity simply by observing the distribution, because I can imagine that maybe other factors play a stronger role. Should publish a book on experiments. Actually, Microbehunter experiments. Actually, this is, me publishing a book with experiments is actually something that I've been thinking about and actually already collected ideas. But they are, a work in progress. It takes time. And that's maybe one of the things that deters me a little bit, okay? Or they simply avoid the metal. You see, not the metal itself, but because of the oxidation that happens, it could be that some of the copper creates maybe copper ions or so, which could be harmful. So yes, the chemical reactions that happen can indeed be a problem as well. The DC current might be in the microampere range. Yes, this is quite well possible. Okay. Wouldn't you kill them with salt if the salt concentration is too high? Yes, and I'm going to show this to you later. Okay, when I show you some of the videos. I remember that Microbehunter said that microorganisms did not like metals. Yes, in ionic form. Some metals, right? Like when you drop a copper coin into the well, there would be a ring around it where the algae didn't come near. Yes, this is indeed something that I was able to observe. The water has to be still and standing, but around the copper coins, which corroded, really the algae didn't grow for several centimeters across. Yeah, so evidently there was a high level of copper there. Okay. Polarity, okay. Oh, I just thought of an experiment collecting microbes from a source with loads of iron and then placing a magnet next to them just to see whether they would react. I think rust, iron oxide, is not magnetic. So even if they were to take it up, they might not respond. Okay. You know what I'm going to try now? Again, and this is a little bit of this is highly experimental what I'm going to do now, okay? I'm going to now, I've not tried this before, okay? I'm going to now try to take some of the vinegar eels that I have, which are nematode worms, and I'm going to check how they respond, okay? But no guarantee, no guarantee that it will work, okay? So I'm going to completely clean this off again here. Okay, so let's remove all of these things here. Look at this. Ooh, I bent the wire. Doesn't matter. Just bend it back. Okay. It could also be that with time, as the wire starts to oxidize and corrode, maybe that this also kind of limits conductivity a little bit. Okay, but this is going to be now vinegar. It's going to smell really bad. Okay, but you won't notice that. But what I have here is, and I need to explain this. Look, I need to get the cover glass away as well. Okay, let's do it like this. So I need to explain this a little bit now, and no guarantee that that we're going to get any response. I have to repeat this, otherwise we're all disappointed, including on myself. Okay. I have over here a little jar with so-called vinegar eels. These are nematode worms, and yeah, they can be bought as for fish food, aquarium food, and this has been growing now for over a year. Occasionally, every couple of months, I added a few drops of yeah, you can add some apple juice a little bit, yeah, and then I also tried to reproduce them by putting them into a new jar. Some of them with apple juice. This was pure apple juice now without vinegar. And I can see actually they're floating around. They are starting to reproduce. You cannot see that because they're too small. I can see there are some, it's a little bit cloudy, so they are living and thriving happily. And I'm going to now take a few of those guys, and I'm going to put it now also on the slide. And yeah, let's try it, and let's try it. I'm going to take it from the very bottom, and again here. Maybe not too much, because if this spills over, it's not so cool. So, and of course a cover glass goes on top again. I don't know where I put the other one, so I'm going to take a fresh one, and as always I'm going to wipe it. I have no idea how this is going to work. I have no idea if they respond at all. I have really no idea. Maybe they do respond, but we're not able to see it because they're wiggling around so much. Let's put this on here. Let's close this off, and microscope scene again. Carefully put it on here again. The good thing about those nematodes is that they're pretty huge, so they're much easier to see also on the low magnification. Okay, don't want to spill anything, that's the thing. Okay, let me see. Okay, here we go. Here are the worms. Let's have just a look. Okay, it makes contact over here with the electrode. It makes a contact on the other side with the electrode. There are lots of them here. Okay. I'm going to start, did not connect it yet. I'm going to start at a very low voltage because I don't know. I'm going to start at 0 because I don't know how sensitive they actually are. Okay. So one of them is connected. The other electrode is now, I've got 0.5 volts, very low. Okay, almost 0. And what happens if I go up with the voltage? Does something happen or not? Some of them seem to start to move a little bit slow. I don't know. Okay, here's more going on. So I've got now 4.6 volts. I'm going up with the voltage. Yet more up. More up. 8 volts. Let's have a look at some of the larger ones here. 11 volts, 13 volts. Let's check the electrodes if there are bubbles forming. Yes, there are bubbles forming, so this basically means there is current. Go up yet more, 15 volts. Yeah, they start to, I don't know, 16. Do they change in their behavior? Some of them seem to move a little bit more irregular. 19, 20 volts. $24. 29, now I'm at the maximum. You look, lots of bubbles forming here. There are a lot here, but this could be maybe because it was denser here in the first place. What about the other side? And there are also some. Well, I don't know. If I disconnect, what happens? Now it's disconnected. I don't see a big difference. Connected, disconnected, connected, disconnected. Nematodes don't seem to mind. And I'm now at almost 30 volts. Connected, disconnected. Okay, well, we've also learned something here. Despite the vinegar, I don't have any current. So it might be a very small current. Yeah, okay, that's an answer as well. There seems to be no response here. Okay, well, so be it. Okay, yeah, I'm going to go through a couple of the comments again. Okay. Yeah. I think you would enjoy visiting the Museum of Natural History with your friends and family way more than the dubious. Yeah, it appears that majority of organisms follow the current flow rather than electron flow. Yes. Current flow is in the microamps. Okay, microamperes. Would you consider to add a variable resistor in the range between 10 kiloamps and 100 to next time, which would help control the amount of current flow in the microampere range? Okay, that would be a possibility. Whether it's actually the ampere that the amps that count or the voltage. Okay, that would be possible. That slide is very cloudy. Yeah, there are lots of impurities in here. Okay. So I'm again skipping over the comments. Do you know why vinegar eels live in vinegar? Well, I can tell you that because they naturally live in fruits. So, for example, if you've got some apples lying there, and then there are the eggs of these. These are not eels, of course. These are nematode worms. Then when they start to reproduce there, and they convert the apple juice into vinegar, and they basically make it acidic. And so it's not that they want to live in vinegar, but they're used to an acidic environment because they themselves are able to process juices, apple juices, for example, and when apples fall down, and then they're able to produce vinegar. Okay. Okay. You know what? I'm going to quickly do the very last experiment. So we've seen that this does not work so well, or I mean, what I mean work well, simply don't respond. And this is of course now the time when I have to also kind of remove this here. So a couple of thousand nematodes now on my tissue paper. I'm going to take another fresh tissue paper here and to clean everything off. Okay. I didn't switch the camera. It smells pretty bad. So let me quickly change the camera again. Okay, I have to wipe it again because with all of the vinegar on here, you know what I'm gonna do is I'm not gonna wipe it, I'm going to simply flush it because it might change the pH of the next sample. So I've got some water here. Just flush it. So that's basically all I'm going to do now. And I collected, and that's the last experiment for right now. This is simply a water sample with some algae and also some microorganisms in here. And it's directly quite fresh from a fountain. And and I know that there are also many of them in here. And I would like to have a look now at those to see if basically some of them respond as well. So let's do that. cares even if it's a little bit dirty, who cares? Let's just give it a try anyway. Okay, again have good contact with both electrodes. And let's give it another try. So, okay, let's see, where are the algae? Okay, there were more things in the morning. Not very exciting. Okay, well, maybe at a slightly larger magnification. Yes, here we go. Okay, let's see if they respond to electricity. Because these are also some, again, different forms of different ciliates here. Let's add a little bit. Let's do it like this. Let's do it like this. This is better. So again, the problem that I have here is that I think that the sample is relatively thick. What's that? That's a rotifer. So let's try to find a place where there are a few more. I don't know, there are a couple here. I don't know. Let's go down to so, and now it is connected again. If they start migrating, there are simply too few of them to actually be properly seen. Yep, and they're difficult to catch. Okay, well, this one over here doesn't seem to mind so much. Oh, it's a very low voltage that I have. Where is the... 6 volts. Let's have a look at those. 7 volts. Do they go into a certain direction? 10 volts, 11 volts. Nope. 16. $28. Oh, but look, there are some others. The smaller ones. Some smaller ones seem to be moving. Here's the negative pole. So that's the negative electrode. It's too small to see. Yeah, not very satisfactory. Occasionally, yeah, here's one which has a pretty directional movement, but because of the thickness of the sample, it's a little bit difficult to keep them in focus. What about those two guys here? It's almost like they want to move away, but they're always pulled back. Okay, 14 volts. Okay, yeah. Let's. So this is basically a natural water sample, and I was kind of hoping to find again different ones here. So let's have a look again at a few questions. What time is it even? Let me check. Oh, I'm already talking 1 hour. So that's pretty interesting. I never really knew what nematodes really eat. Well, I mean, they do have a digestive system. They eat bacteria. Some of them probably also absorb nutrients over the skin. Okay, so So maybe the activity of the water is already very high, so it doesn't change as much, could be. So if you answered it, but I'll go back to listen. Paramecia are distinctive. It's a difficult process to identify the more generic looking ciliates, yes. How about just a magnet, then a magnet moving in and out of a coil conduct? Okay, that's, yeah, with a neodymium magnet it might be possible, but it's possible to use magnets also to collect certain bacteria. So what you do is you take a water sample and you place a strong magnet on the outside of the jar, and then sometimes bacteria will accumulate on the inside. Okay. We did not even look at the old microscopy videos yet. Yes, I'm going to do that. Okay. Had an impression that under the influence of the current, the worms were less curled. This could be. Okay. You know what I'm going to do? I'm going to, yeah, very quick last look of what's going on here. And there are not so many over here. And yeah, there are more over here on the other side. This is again one of those demonstration effects, because today in the morning I should have taken a video, but then I said it's so easy that I can reproduce it without problems. I had all of the Paramecia lined up in a very narrow band. Okay, but what I will do is the following: because obviously this is not going to be the first and not the last time that I'm going to experiment with this. I'm going to make anyway for the main YouTube channel. I'm going to make a video, so where I'm going to video it a little bit better. Okay, so where we're able to see this better. So and then I'm going to edit it down and so that we're able to see how they actually move left and right much better. Okay, so it's 13 volts right now, and yeah, you know what? I'm gonna, if I turn down the voltage completely now. Then let's see what happens. Let it start twisting. Now 0 volts, almost. And I'm gonna go all the way up again. And let's see what happens. Okay. All they do is change the behavior. Under high electrical voltage, they kind of seem to move a little bit less aggressively. So, okay, yeah, you know what? Let's move on, okay? Because otherwise it's getting a little bit tedious. So I'm going to quickly turn off the power supply. Okay, and I would like to completely switch topics now for a couple of minutes. And today's live stream, I don't want to be too long either. I just want to show you a couple of very old videos and comment a little bit on them that I made 23 years ago. Okay, and just a short background information. I started microscopy, being serious about microscopy, around in the year 1998, so it's quite about 25 years ago. I used at that time, there were not so many microscope cameras available. So what I did at that time is I got myself a very cheap webcam. Webcams already existed, but they were pretty bad. 640 by 480 pixels, very low resolution, very slow. And I connected one of them to my microscope, but they were so slow that I could not do any videos. So the computers were also extremely slow at that time, and the only real way to do videos was to use an analog camera, a video camera. And the problem is, how do you connect a video camera to a microscope? You don't. Well, what I bought myself is a fairly cheap surveillance camera module. It was about this size, and yeah, it was like one flat thing, and there was a sensor on it, and I could connect a television, an analog television, directly to the surveillance camera without computer or anything. Simply by taking a cable and connecting it. And this kind of worked really surprisingly well. And if you can connect the television, then of course you can also connect a video recorder. And this is what I've done. I connected a video recorder and I videotaped approximately 2 hours of footage of everything of water life. And I just recently rediscovered this videotape, and I then pulled out my old video recorder and I connected the old video recorder, and I was able to capture the image and the video, and I've got it now on the computer, and I simply would like to show this to you. and here it is. Okay, so this was actually one of the first videos that I used using an analog camera, and the reason why, and I was quite happy at that time. So it looks a little bit colorless in black and white, and it was actually a color camera, but the image quality at that time simply wasn't as good as these days, but still I have to tell you a little bit positively surprised how still 23 years ago how good the quality was. I did not edit anything here. I did not increase the contrast. I just left it as it is. So I did a lot of video of a rotifer. So the dynamic range, of course, was quite low. So this means that also the resolution is not very high, because this is a very low resolution camera, pi. So it's around 500 pixels by, I don't know, 700 pixels or so. Yeah, of course, and also here again a paramecium. So I have to tell you, I was a little bit surprised that how much technology and how much the image quality actually improved over those 23 years. At the same time, I was also quite surprised at how much one could already see at that time. At that time, of course, I could not share all of those videos because this was way before YouTube. And I could have probably shared those videos, but I didn't remember that I actually had the tape. So is a comment here still very good for his age? And yes, I have to say that's correct. See, I was, but it will continue. Yeah, and of course a nematode worm. Okay. Also, interesting to see a little bit. Maybe I'm going to do the following now. I'm going to press pause, and press pause again. And do you actually see that despite the rapid movement, you actually get a pretty sharp image with relatively little motion blur. So those analog cameras at that time, they were able to capture, it quite well actually, because one would probably expect that it's going to be very blurry because of the rapid movement, but actually it's not. So it was a very simple, very low-cost surveillance camera module. Look at it, a mite. And I used this surveillance camera modules also because of its small size. So I actually was able to ask a friend to CNC cut a case, so I could put it in there, and I could put it on the trinocular head of the microscope. And I was able to use the objective of the microscope directly to project the image. So I was actually only able to see a very small section of the field of view. So it was took a lot of patience really to get everything properly aligned. This is and over 2 hours. Very I recorded a lot, and then never really watched it. So actually, this is one of the first times when I was watching it. But I do want to move forward a little bit here as well. Okay. This is a worm, Iolosoma. As well. Again, the mite. I'm going to move forward a little bit. Some insect. Let's go back a little bit here. Huge antenna. I found some kind of a dead insect in the water sample, which I also recorded. And this is a very nice example of a dynamic range because some people asked me about microscope cameras and what are some of the aspects that are important for microscope cameras. And resolution is only one thing, but what we see here is that this camera had a relatively low dynamic range. If you look at, for example, at the head of the insect, it's completely black. I'm not able to see any details, and the background is completely white. I'm also not able to see any details, and that is a sign of low dynamic range. And modern cameras not only have a much sharper and crisper image and a better resolution, but also a better dynamic range, so we are able to see the color differences better. Again the worm here. And there's a comment here, might be worth uploading it to the main channel, and as a matter of fact, I'm working on a video on that. Here you can actually see this line, because. Which actually shows that it's recorded in analog on tape. So I'm actually preparing a couple of videos where I'm showing those. Yeah? This is some kind of a water crustacean. Yeah? Also, when you press pause, yeah, it's actually kind of surprising that you're able to see the rapid movement of the organs. It's also frozen in time, which kind of shows that the shutter speed of this camera must have been fairly fast. Yeah? So I'm actually quite surprised, positively surprised, that for that time it was actually fairly good what you could produce. Yeah. Yeah. Again, no color adjustment, and something that was also a little different, and I had to readjust it is a little bit because now we have got 16:9 at that time with 4:3, so the aspect ratio was a little bit different as well. Yeah. It looks colorless though. Yes, that is correct. Somehow, yeah, that's dark field. You see a little bit the noise. First of all, the sample did not have a lot of color, that's correct. And I think, yeah, some of the colors might have been lost a little bit. I know that if you store tape, I was told this, if you store magnetic tape for a long time, even if you do not look at it, magnetism gets lost, and therefore the quality goes down as well. So this might have, yeah, so it could be that several years ago that the color quality might have been even better a little bit. Simply because the way that it's stored is in an analog form, this way you kind of lose quality as the tape starts to demagnetize over time. I don't know if it has an effect on color as well, but yeah, but I do remember that that it was a little bit more colorful before. Yeah. But maybe I'm able to get out more colors by doing some color adjustment, but I didn't do that now. Yeah, also, yeah. Here, this one, of course, you all of you know that. Yeah, that's Vorticella. Look how quickly, yeah, it was able to retract. Yeah. Yeah, so also the movement again. If you, yeah, you're also able to see the movement of the little hair of the Vorticella. Fast forward again here. I don't have yeah, just a couple of more minutes and then that's pretty much it. Yeah. Maybe it's gonna, yep, here it's able to contract. It contracted again. Yeah, and this is actually I'm gonna make a video of this. Look at this. This is a fun thing here. Just a second. Yeah, this is a Paramecium, and I just wanted to look at the organelles and look what it's doing. Just a second. It's expelling some of the wastes. Yeah. It's called the cytoproct. That's also known as the anal pore, where the Paramecium. It was pure coincidence that I was able to observe this. So we're simply expelling some of the undigested material. So actually, I'm including this little footage here in one of my videos that I'm going to put on my main channel. Yeah, and we're at the beginning again. So I simply only showed you a couple of the clips because it's almost 2 hours long. Everything, yeah. A microorganism going to the toilet. Yep, as a matter of fact, that's basically what's happening. Yeah. Yeah. So I'll quickly have a look at some of the comments that I might not have answered yet here. Nematodes seem to be very resilient and electricity does not have much impact. Can we conclude that they're not electric organisms or voltage current not high enough? Let's put it this way. All organisms that have a nervous system, and even many microorganisms that don't have a nervous system, they rely on certain very small amounts of electricity. Either on the membrane potential is electrical, the nerve impulse transmission is definitely electrical, and I'm quite sure that many of the microorganisms and also nematodes might be able to be influenced by electricity, but maybe we don't have the correct current or the correct voltage, or maybe the only small impulses are able to cause a response, or maybe they cause certain responses and we're not able to see them, right? So I wouldn't be able to say that specifically, yeah? But I would say that all organisms that have some kind of a nervous system, you might be able to trigger this somehow with electricity. Yeah. just join seeing the electrodes. What's going on looks like is seen from Frankenstein lab. It almost is a Frankenstein lab. I was applying a little bit of electricity to a water sample with some cells, and the cells were actually going towards the negative pole, some of them. Yeah. I removed the lens from an old flatbed scanner a few months ago, and today I used it as a microscope lens. It's actually great. A free 4x plan lens, almost APO corrected. And what else you can do is, if you want to make your own microscope objectives, you can also, if you're able to get an old DVD player, there is also a tiny laser lens. Some people have been also playing around with that, with those lenses to place on, for example, the lens of a mobile phone, and then you can also make a microscope. So laser lenses, for example, from a DVD or CD player, actually apparently also work. Never tried it though. Okay. Have you checked the bacteria that are in the mouth? I wonder how the mouth bacteria look when you have the so-called SIBO syndrome. I don't need small. Oh, okay. I don't know about the syndrome. There are so many bacteria in your mouth that I mean, I tried this once. So many of them, you won't be able to identify them. You can just see the different shapes, but there are probably, I don't know, hundreds, if not thousands of different species of bacteria growing there. Have you checked the bacteria that are in them? Okay, I already read that. Okay, an optimized protocol staining for ciliated protozoa. With the idea to control them with a joystick, you inspired me to create a joystick-controlled slide mechanism. That's as a matter of fact, if you are interested in actually controlling the microscope slide, if you're a little bit into Arduino programming or so, and using stepper motors, I actually tried to do this as well once, but it was too elaborate to control the mechanical stage using a joystick and stepper motors and so on. Yeah. Okay, thank you, Oliver. As always, interesting shows. I have a question. Do you have a Swift 380T microscope as one that you have? And SLR camera, what adapter do you recommend? I've got a Swift 380T microscope. It's currently packaged away in my cellar, but occasionally I do use it. What do I use? Well, I did make in this channel a couple of review videos about SLR adapters several years ago. There is an Amscope one. I got a fairly cheap one also from AliExpress from China. The one that I have is, it kind of works. Yeah, it's not absolutely great, but it does its job and was fairly cheap. So I cannot specifically recommend it or disrecommend it because there's simply not a lot of SLR adapters, DSLR adapters for cameras around. So what I would simply try is I know that Amscope in the United States, they're selling DSLR adapters. I've not tried those. Yeah, I guess it depends. You just got to try it and see if you're satisfied with it. Yeah. Yeah, I have a very, maybe the old tapes look better on original old CRT monitors and VHS players. When using adapters to record transmitted signals, they lose their quality, color goes first. Every time, yes. Every time when you capture something, and I used a little digital capture device where you can actually connect it on one side HDMI and on the other, it was actually like this. I got the analog out of the video recorder. I converted it to HDMI, which is a digital signal, and the HDMI I converted to USB to feed it into the computer. So there is lots of conversion going on. And every time when you convert a signal, of course, you lose a little bit of image quality. So I wouldn't be surprised if maybe some of the image quality indeed got lost also during this conversion process. Okay, yeah. You know what I'm gonna do? I'm just going to call it quits now again, because I've been talking 1 hour 20 minutes today. And just as a little information, I'm going to work again, of course, on those Paramecia, and I would like to make a video where maybe I'm able to show this galvanotactic movement of the Paramecia much better. Then you just simply can watch the video. It's going to be in my other channel, however, right? And it's going to be much shorter than the whole live stream today, just maybe 5 minutes or so, where I'm going to summarize all of the points. It might still take me a couple of days to do that, because I would like to get very nice images I think as a last comment, I think one of the things that people keep on emailing me and asking me when they've watched some of the videos in my other YouTube channel, in the main channel, is wow, why is your image quality so good, and all these things, and how did you do that? I will tell you right now, I'm only it does take quite a bit of video editing to increase the color contrast. And the way what you see nowadays, right now in this live stream, where sometimes things don't work out right away when I show them, that is the normal, right? But in the videos that I present in the other channel, you only see the good, nice end result. But what you do not see is all of the trial and error that was involved and all of the experimentation that was involved. And of course, I'm not showing you the videos that do not look so good, right? So in that sense, it can be a little bit misleading when you look at the videos in my other channel and you say, wow, everything looks so great and so easy. Sometimes there was a bit of work involved and editing involved and experimenting involved until I got to that point. And now in this live stream, you see a little bit the contrast of how it is actually really like when you simply take a sample and put it under the microscope and you expect to see something, and sometimes it doesn't always work, right? That's almost the norm. Yeah. So I'm saying this so not to get discouraged, because I do get a lot of emails with people asking me, oh my gosh, I tried to find Paramecia and I never found them, and this didn't work, and the image quality is so bad, and so on. And I'm just saying, well, keep on trying, yeah, because that's what I'm also doing, right? Okay, just wanted to say this at the end here, right? So, and this gives you a little bit of a kind of look behind the scenes, so to say, of how actual everyday microscopy looks like. People, I'm gonna call it quits for today again, okay? Yeah, I'm going to leave it at that. Again, I wish you a nice day, nice weekend still. Hopefully to see you again next Saturday with a different topic. I still have to think of the topic, but I'll come up with something. So maybe I'm able to find a few more ideas with this power supply that I have got right now. Okay, yeah, I should continue your book. I'll be honest, last comment, I already have over 200 pages of the book together, and I'm not happy with it. Therefore, I did not complete it. I got carried away and got too technical. But maybe a simple book with, I don't know, 20, 30, 50 interesting experiments or observations. I think I might be able to put that together. Yeah, wish you all the best. All the best. Bye-bye. Happy microbe hunting as always, and see you around next week again. Bye-bye.